Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the course electronic circuits, and the topic which I'm going to discuss here is about common emitter amplifier. So before that we must know what is amplifier and how it works. So let us first discuss about the working of amplifier and what amplifier is. So we know that the amplifier, it is a device which is used to boost the signal strength. So a weak signal is converted into strong signal with the help of the amplifier. So we can tell that the magnitude of the signal which is applied at the input can be increased at the output with the help of the process amplifier. So that is what is given here in the block diagram. You can see that there is a small signal input which is given at the input of the amplifier circuit, and the gain is always the ratio of output to input. If it is voltage gain, it is output voltage by input voltage. If it is current gain, it is output current by input current. So that is given here, and we can see that after this amplification process, the output is the larger one compared with the small input signal. Thus, the amplitude is increased here. So the amplifier is a process where a weak signal is converted into strong signal, or the signal strength is boosted up here. Or you can tell that the magnitude of the signal is increased at the output. So this is all about amplification process. So how actually it works? Let us see an example. So this is a simple example for amplifier circuit. So here initially, so we have a microphone. So this is a transducer which converts the sound energy into electrical energy. So when we take a mic and when we start speaking, our sound energy is converted into electrical energy with the help of microphone. So that electrical signal is then it is given to the amplifier circuit. So this is our amplifier. So what this does is it modifies the larger current based on the smaller current. So this is the circuit which is carrying larger electrical current, whereas this is the circuit which is carrying smaller electrical current. So at the end, we could see that the speaker, that is loudspeaker. So when I talk through a mic, what happens? Amplification occurs, and at the speaker, through the help of the speaker, we could hear the larger uh, voice, right? So what it does is loudspeaker again it converts back the electrical energy into sound energy. So this is acting as inverse transducer, and this is acting as a transducer. So this is the simple example of a amplifier circuit. So when we talk through mic, through the speaker, we get the amplified output. So let us see the major classification of signal amplifier. So here there are two types based on the signal, that is small signal and large signal. And based on the configuration, we have common emitter, common base and common collector. And normally based on the operation, we classify as class A, class B, class AB and class C. So these are called as the power amplifiers. And based on the frequency of operation, so we have four different types here: DC, audio frequencies, radio frequencies, very high frequencies, ultra high frequencies, etc. So these are the various category of amplifier types. So now coming into our topic, that is common emitter amplifier. So this is the BJT common emitter amplifier. So here we can see that the input is applied to the base. So this is our input signal. It is applied through the base. And we could see that the output is taken from collector. And the emitter here is common to input and output. Hence, this is the common emitter configuration circuit. So input applied to base and output is taken at the collector, and emitter is common to both the input and output. So see, normally the common emitter amplifiers are having high voltage gain and high current gain, which means the power gain is ultimately high. So therefore, this type of common emitter amplifier is preferred most. So, and at the biasing, we could see that voltage division occurs. Voltage divider biasing is given at the input, and you could see that the signal, small signal, which is applied at the input is getting amplified at the output with 180-degree out of phase. There occurs a phase shift here. So this is called as common emitter amplifier. So this is the characteristics of common emitter amplifier, input and output characteristics. So from this graph, it is understood that the input characteristics, that is IB versus VB, input current versus input voltage. When we see the relation, you could see that after the threshold voltage of 0.2, there is an increase in the collector current at different values of collector emitter voltage for 0, 10 and for 20 volt. So this is the threshold point. And as far as the output characteristics is considered, it is the relation between VCC and IC, that is your output current, which is called collector current. So in this case, you can see that there is a operating point which is lying in the center of the DC load line. So this makes the transistor to work as an amplifier circuit. So this region is our active region. And you could see that the different values of current where the collector current increases can be seen here. So the main characteristics of the common emitter amplifier are, with respect to the parameters, the input resistance is moderate, output resistance is high, voltage gain, current gain and power gain is high. And there is a phase shift of about 180-degree in common emitter amplifier. So today's assessment lists the advantages of common emitter amplifier. The common emitter amplifier is advantageous because it is having high current gain, voltage gain, which means power is equal to V into I. Therefore, the power gain is also high, which indicates good amplification characteristics, and it is having medium input impedance and high output impedance. This makes it suitable for voltage amplification and impedance matching. Thank you.